let's see if I can get this up. All right. Okay. Well, everyone can see this. There we go. We'll figure it out. Oh. I'm going to pull up your homework so I can see it on my other screen. Hold on. This will be recorded, and I will put it onto, make sure that's off. Okay. This will be recorded, and I'm going to be putting it onto Blackboard as well. Okay. All right, let's pull up. Give me 1 second to pull this up, and we'll get there. This is annoying. Let me see if I can get this back. There we go. Messing with this because I haven't shown my whiteboard on here before. Okay. Let's pull up your content lead page. Okay. I'll show you what I'm pulling up on my screen now. All right. Okay. Let's go. I'll just pull it up on your screen as well. Share my other desktop. There we go. You guys can still be on this desktop. Okay. All right, we'll start in a minute. I need to run for a moment, but I realized I started to erase this. I didn't erase it fully, so it should say hello. Hopefully everyone can see this. If you cannot see what I have written, let me know, but I'm pretty sure it comes out properly. Stupid backlit of this. Can't really control that. I'll try to stand in front of the window. I'll be right back. Okay, let me make sure. My announcements. All right, how many people do I have here? Okay, well, we'll get started. Let me pull up this here. So looks like people got through it reasonably well, but I'm going to use this here to just make sure that everyone understands the basics of mapping. Let me close the door over here. Okay. All right. You are all muted right now, but if you would like to talk, just feel free to, you can just turn on your microphone and say something if you'd like to. I think everyone is muted right now, so. I've learned from experience with a couple of other ones that if I don't mute everyone at the beginning, then half the meeting is just, can everyone mute their microphones? Okay. You guys can see my screen, right? So my question for everybody here is, can you tell me if you can see my screen and me? Are you able to manipulate it so you can see this too? Or would you like me to switch back and forth from showing you my screen to showing you only the board? More information. I don't have this. I can't tell what you are seeing on the screen. If I'm too small, you couldn't see me draw on here. You can't read the word hello here.
Too small.
Too small? Okay. What I can do is, I can shift you, after I walk through the problem. So I would suggest on your computers, pull up the problem behind so that you know what I'm talking about. I'm gonna be able to see the problems the whole time because they're behind me on my second monitor. But when I'm working through them, I'll pull it up so I'm full screen. You can make me full screen at any time with Zoom. If you go into the, let me remind myself how to do this actually. So you can also click on the act. So if you go to the top of where my little picture is, you can say show active speaker video. Oh, no, hold on. You can show a grid, but I think probably it's gonna be easier if you just show, let me go back real quick. I'm gonna stop sharing for a moment. Okay. So if I'm too small, to make sure that you are making it, you can click on me and go and say either, you can say pin video. So click on the three little dots above my name and say pin video, and you'll be able to see just me. No matter who else is talking, you'll be able to see me and my whiteboard. So if everyone wants to try that real quick, I can't see your screens, but you can read this. Is this forward for you? Just making sure. This goes the correct way for you, correct? You can see that it says hello.
It does. Yes, it does.
Okay.
It does.
But as long as it's showing you not mirrored, it's fine. I'm used to seeing myself in the mirror. That's probably why it's doing that. Okay, good. Again, make sure that if you want to see me while I'm talking, when I'm not sharing my screen, just click on my video up above, say pin video. It will put only my screen. It won't switch back and forth. You won't have to look at everyone's empty screens, okay? But let's go back to my screen real quick. Let me share my second desktop. There we go. Okay. All right, let's look at the questions here. But I'll walk through. And again, if you want to pop in and say this made no sense, or please go back to the beginning of X, that's fine. Okay, let's go through and see what these are. I've forgotten already what problems are. Here we go. Okay. All right. One crossover decreases the likelihood of crossovers in nearby regions. That's positive interference, okay? And that's what we were calculating with that, the coefficient of coincidence and the interference values. All right. Okay, genes A and B are 10 map units apart. Genes B and C are 20 map units apart. Gene B is located between A and C. All right. First, let me draw the map for you guys. This is asking you the amount of double crossovers for a trihybrid test cross. Okay, how many should you expect? Remember, it's sometimes different because of interference, but let's try to figure out how many we should expect. This should be reasonably easy, but I'm gonna point out why it is the way it is. I see that some people, a few people got it wrong. And so I will walk through it, but let's go back to, I'm gonna unshare. I can make sure I'm pinned so you can see me. And I'm gonna walk through it, okay? So we have, I forgot to bring my eraser up. I have a sweater though, okay? We've got a map. Okay, our map includes A and C, B. We know how long these are. A to B is 10, B to C should be a 10, make it a circle, there we go. B to C are 20, okay? Remember that this represents 10% crossover, 20% crossover. Block the light here, there we go. 10% and 20%, okay? Which means 0.1, 0.2, 0.1 times 0.2 equals, who could tell me? 0.1, 0.2 times 0.2 equals?
0.02.
0.02, okay? So that's the answer actually. If the probability of crossing over is 10% here, probability of crossing over is 20% here, 10% times 20% is 2%, okay? So that is going to be the answer for this homework number 7, the chapter 7 multiple choice, okay? So this is what we should expect. So if we had 100 offspring here, we should expect 2 be a double crossover. Which is why generally for the fruit fly studies and such, they have thousands of offspring, because you get so few, and even a small randomness variation can make it so you don't get any. Okay. It's an and problem. Anyone have trouble with this? Move on. You can, if you go down to the bottom and press reactions, you can give me a thumbs up. Okay, Ebere is good, but see thumbs up from many people, not everybody, but if you are confused, let me know in the chat what I need to explain. Okay, I'm gonna move on. Let's go back to my screen sharing. Here we go. Moving forward. All right. Okay. I'm sharing. This says, why do mapping experiments become less accurate when the distances between genes become large? All right, because multiple strand exchanges are more common, the idea is that if the distance is very big, you're gonna see a pattern similar to if they were on 2 different chromosomes, because it's more common that it will cross over. Remember that 50 map unit? That's the requirement there. You can't really tell how far they are apart once they start getting too far apart. Let me see if I can actually, I'm gonna turn this off for a second. I'm gonna look at student view, that's what I want. Because if I look at student view, then we can figure it out before we move forward. Okay, here we go. Now, All right, this is the positive interference. 2%. Okay, that's better. All right, I gave you some big ones here. Okay. Practice problems. So here we have Drosophila. It has 3 genes: eye color, wing shape, and wing length. Okay. Purple eyes, bent wings, and vestigial wings are the mutant forms of the wild type traits. Okay. So we now have information that VG and PR are 12.5 apart. I don't know if it's scattered this for you, so don't worry about the numbers, just understand the pattern of what we're doing, okay? VG and PR is 12.5 MU. A and PR is 44.7 MU. A and VG is 32.2, which is in the middle. You guys understand how to find that with this question? How do you find the middle one if you just know the distances?
I think the shortest distance, VG and PR.
So you have the shortest distance, but the key here is you look for the longest distance.
Oh.
And those are on the ends, okay? That's the deal. This will tell you the order. The gene in the middle can be deduced in this situation by looking at, you note that A and VG, 32.2, PR and VG, 12.5. So now we have VG as being in the middle. Okay. So I'll draw it and it'll make more sense. Once again, regretting not bringing up I'll pull it down and I'm gonna pop this up, okay? So you guys can all see me in bigger screen, okay? Great, I just pressed this button to stop sharing. Okay, so let's draw it. The answer is that all the numbers should make sense on this if you did it right. Okay, we have, so let's look at my assumption and see why I thought it. This distance here, so there's VG. Doesn't matter which one you put where. Let's put A and PR, okay? This is obviously not proportional because I know one of them is much smaller, but let's just work from here. I know that A to VG is 32.2. And I know that VG to PR, 12.5. If I add these together, I should have the distance from A to PR. The longest distance represents the ends because it's the longest distance apart, okay? You have 44.7. These two added together equals 44.7. Therefore, these two have to be at the ends. VG is in the middle. Understand? Thumbs up. Okay. Fanny understands that. And I see other thumbs up, which means this is working. Okay, good. And if you ever are not thumbs up and you don't know what I'm talking about, please tell me. Okay. So we have VG. Let's go to the next question. Begin studying them. Female and male flies. Okay. Let me go to the screen share again because this one, I'm going to show you the numbers and then we'll come back. Okay. Share my numbers here. Okay. All right. Here we have the heterozygous females. Remember the pluses just represent the dominance for each one. You don't have to have the plus whatever, okay? So now you have information that VG is in the middle. And so we should know what to expect for the single crossover events and the double crossovers. The way to tell is this. These are heterozygotes, remember, okay? So these are the three. We have plus, plus, plus on the other chromosome below it, okay? Let me pull my big screen up, sorry. Stop it. Plus, 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 okay? We want to know the crossover between PR and VG, okay? So when a crossover happens here, what do you expect to see? Basically, you're going to expect to see that PR will move and the others won't, okay? So if PR moves and the others don't, then we need to see what we would expect. So in that case, you would get, let me just erase this real quick. We would expect to see one that looks like AVG plus, plus, plus PR. Do you see that's a single crossover for that? Okay? So that's what you would get for this region crossing over. Only PR would move, not VG or A. So in that case, here's my shared screen again. In that case, we are expecting a plus plus PR. See where we can get that. There we go, plus, plus, and PR. Okay, this is in the right order, but whatever. Plus, plus, PR, A plus V. That's gotta be that one. Who is confused about what I did? Does anyone want more information? Please use your microphone to say words if you don't know. I have the chat somewhere, but I have to pull the chat up. Where's my chat? Oh, no, someone chatted in here. Here we go, okay. Does order matter? Yes, for this one, order matters, okay? Faye is still lost, okay. We're gonna figure it out, we are. Here's the deal. If you know the order and you're asked what is the result of a, what is the result of a crossover between the two? The crossover is going to move this part, okay? And you need to know what it moves. Again, it doesn't matter what order it's written in the answer, just as long as you have, because what you're gonna expect with no crossovers. No crossovers. We're going to assume this is a, let's just fully assume for this, so we're asking why it moves the PR. Okay, that's a good question. We're going to talk about that right now, okay? So we're going to assume for this question, let me move here. Remember, we know that VG is in the middle. Doesn't matter how you are organizing it. They put it APR VG. Remember, VG is in the middle. That doesn't change. Use our map. Write the maps every time, okay? So, Faye, you understand how the map works? Why the VG is in the middle? Okay, great. So as long as you understand why VG is in the middle, then you can understand what's happening here. Let me go back to my main screen here, okay? All right. Here we have, try to block the light as much as I can. Make everything dangle. Okay, here we go. Okay, the crossover is happening here. Slice. The crossover happens here, in between these two. Then it moves, it swaps this part. It cuts here and swaps this. That's what the crossover does. So if a crossover is happening between them, it's moving this part to the other chromosome and leaving these two here. Therefore, in a recombinant, in a single crossover, PR will be on one side with both positives. A and VG will be on one side with one positive. Remember that, don't worry about the order in the, now that we know the true order, don't worry about the order that they put it in the answer. Because they organized it A, PR, VG, which is not the right order. You can write it out the correct way and figure out which one matches it. This is what I did, okay? It moves the PR because that's what a single crossover does. Again, this is 2 homologous chromosomes in a homologous pair, okay? Sorry, it's a heterozygote, all right? They're organized with all the recessives on one side and all the dominants, wild type, on the other side. If you cross over once, in between these two, it flips PR with its dominant. If you crossed over here, it would flip A with its dominant. If you crossed over in both, VG would have 2 pluses, and A and PR would flip. Only VG would be different from the parental, the most common ones.
Then wouldn't that be a double cross?
That would be a double cross if it happened. We haven't gotten to the double cross. That's the next question as part of this, okay? But yes, that would be a double crossover if it happened in between here and in between here, okay? Right now, we're only talking about this happening. One cross flips this. This is a flip, and that's what happens. We should expect AVG plus PR. Again, it's different because they organized it differently.
So the middle never switches. If it said it was going to cross between
If it's a single crossover, the middle won't switch. In a double crossover, it appears the middle switches. But technically, only the other two move. Yeah. In a double crossover, imagine it as the middle never moves, everything moves around it. So in a sense, it's sort of confusing here, okay? So you can either see this cross as this whole section flipping, or just as this one section flipping, okay? So whether it moves or not is a moot point, sort of, okay? Just that the crossover is happening in one spot. Okay, good, Jessica understands. Okay, Faye, where are you? How are you feeling? I know, you were feeling confused, and I want to make sure you understand what's happening. My chat, here we go. Chat. Faye, I'm trying to get you back on track. Okay. Again, if anyone needs to meet with me separately, email me with a good time. I'm around a lot. I have a part-time babysitter. I'm a very needy 3-year-old. So I'm going to do my best. I will tell you when it will work, and I will work it out with my husband, who's also here, okay? But I will be able to, I can even sit down with you one-on-one if necessary. Okay, let's move on. Let's go here. Okay, knowing that VG is in the middle, rewrite the female's phenotype. This is what I did, basically, okay? All right. 1,250 offspring. I think this changed for everyone, so don't worry about the numbers, just worry about the process. 1,250 offspring. Determine the number of offspring you would expect to obtain to represent a single crossover event between PR and VG. Let's assume no interference, no extra double crossovers pushing one away, whatever. Let's focus on the number of offspring you would expect to obtain that represent what you see here. Remember, we have our map still. 12.5 between these two. There is a 12.5% chance that's going to happen. 12.5 times 1,250 is probably easier math than I'm making it out to be. But so 0.125 0.125. I'm typing it into mine. Times 1,250. 156 or so should be correct. Oh, hold on. Oh, I forgot the double crossovers. It reminded me that I forgot the double crossovers. Remember that single crossovers also have, double crossovers will also include both of them. So what's the frequency now instead? This is my fault for making it too simple. Okay, 156 represents the number of individuals that it will create as part of a single crossover. Double crossovers also cross over in that region. This is important. Okay, so we got to add these together. Okay, so 156. I'm just going to type it out here so everyone can see it. Okay, we need to add, and then I'm going to actually put the number here. Okay. We need to add the number. So we have 12.125 times 0.322. Okay. So, and this is times 1250. Okay, that's the frequency of the double crossover if no interference happens. So let me quick do that. It's 0.125 times 0.322 times 1250. There we go. That's 50. 0.3. But since it was 156.25, 50.3, 200. So it's let's just add 156.25. All right, that's going to be a total of 200. It's going to be 207. Okay, because that equals 256 point. Oh no, I did that.
No, I think it's one has to subtract 156 minus 50.
No, I don't think so. It shouldn't do that because you're not subtracting, you're adding. Yeah, that's the percentage of all detectable changes occurring between them. So we're adding the number that could happen to number of double crossovers because that is a single crossover as well. So we have double crossovers and single crossovers happening together. So we're adding them together. So this is 206.56, which we're actually going to just take all this out. 207. Okay, hold on. What is it asking me to do?
It's different. Yeah.
Okay,
Yeah.
hold on. I'm going to give the information here because I think they're doing it different. That's right, I did this. 50 offspring with double crossovers. Then we have, oh, okay. All right, I should have added them together, divided by the total number of progeny times 100. Okay. So the single crossover was 106. All right, I was correct. And then the double crossovers are 50. So I just rounded up too much? Is that the answer?
So I'm confused. So we took
206. Oh, I guess it's, hold on. Now see, it should have been 206. I said 207. I think I added them. So that was an error of a tiny bit. It should have been 206 instead of 207. I added together a little bit too eagerly. I should have rounded before. That was the only problem though. It should have been 206. This is right. So it's 50, 106. They asked me to round before, I rounded after.
But that didn't give me the right answer though.
206 didn't give you the right answer?
No, 206 instead gave 164 as the answer.
All right. Let's just go to it. This is the, oh, is that right? Which way? Oh, that's multiple choice. Just gonna go through them real quick. Hold on. So apparently the answer should be 106.
Professor.
Okay, I think what I did was I was imagining it. This is okay. What's happening here is that 156 is including all of the crossovers, including double crossover that was supposed to take out the double crossovers and put it instead of adding them. This was my fault. So I apologize for some of that confusion. What I'll do is I can see where the confusion came from. It should have been more like 156. But because I realized they're asking me to take away the double crossover possibilities, which that 156 included. So that's the confusion there. So my fault for that. So yeah, you subtract. Yeah, Maria is correct. I'm sorry, I didn't mean to confuse everyone. I did it wrong because I was thinking of, oh, we want to include all of them, and double crossovers it represents a single, but it was asking for only single crossovers, and that was my fault. I should have subtracted instead of added, because the 12.5 does include also any double crossovers that would happen there. So we had to remove those, not add those.
So, wait a minute.
It's the other direction.
Say that again.
156, which I figured. So that 156 was actually, so that is an amount that you get if you take 125 times if you take 12.5%, and you take that out of 1,250. But included in that 12.5% of single crossovers is also some double crossovers. So that's together, okay? So actually, this is so the answer is actually, I should have taken out the double crossovers, not added them in, because they were already in that 12.5%. The 12.5% does include single and double crossovers. Maria is correct. I did it the wrong way, and I apologize. So for this question, because it's multi-part, I can give you guys partial credit for the confusingness of this question, but the answer is that you should have at least gotten one of those answers. So if you got one of the closer to those answers, I can give you the credit, but that's the concept. I think there was a lot of people who got that. Again, a lot of people said 156. Okay, so that was the confusion there. So people who got 156, I can give you the credit for that, okay? Because it is worded strangely. I think it should be 156, but it's worded strangely because it only wanted you to include single crossovers, but the 12.5 distance actually represents single and double. Any crossover that happens in that area, including the doubles. So if you want only singles, you have to take the 50 doubles away. Okay. All right, let's move to the next part here. Okay, again, this tells you, you get this, that 50 offspring has double crossover. So we want to actually have only the single crossover. So you have to take this away from your 12.5 number to get only 106, not 156. Okay. All right. 25 offspring were double crossover phenotype, half of the 50 that was expected. So it says now how many offspring that represent a single crossover event between PR and BG are expected? now that you have positive interference, okay? And this has to do with how you measure, okay? So a lot of people got this incorrect here, okay? So it actually does increase the number that happens between the single crossover because you have interference. So you're looking for your interference number, and that's the number that are blocked by that, okay? So to do the interference part, okay, you are looking for, so you have the single crossover, you have the double crossover over the total number of progeny times 100. Okay, so you have the single crossover plus 25, right? So what they're doing here, the single crossover information at 106, then you add only 25 to it. And the reason you're only adding that 25 is that's all that happened, that's all the double crossover. Okay. And then you do 1250 times 100, okay? Solving for this equals 131, okay? I believe there's a different way you can do it, and that's by calculating the amount of interference, the expected versus, you calculate out what is the interference number, okay? So only some of them are realized. And if you calculate that out and then minus that number, or add that number to, so how many were not expressed. So you now get 131. The simplest way to do this really is to take that number of that wasn't realized and assume it's single crossover. Okay, so you take the number that were double offspring, that double crossover, and the number that wasn't realized, you add it to the original. 106, you add 25, that's 131. And so what it is though is that you're saying that if I expect 106 to be single crossover and 50 to be double, but I actually only find 25 double, then the other 25 should be single because of the interference. Don't worry about all the calculations down there. If you find out the double crossover is not realized, then it would be forced to be a single crossover instead. So you're expecting then 131 instead of 106 because the ones that didn't do double crossovers because it was blocked did a single crossover instead. Okay, I know this was a confusing problem. I think you guys did this was another subtract. Okay, so yeah, the wording here was a little weird because it was asking you for single crossovers when instead it should be double crossovers. When instead we worked it out to figure out how many crossovers overall in that region, not which ones were single, which ones were double. But it's the same concept here, is that if you know that there's interference going on, then you should still expect that a higher number of the crossovers in that area will be single instead of double. Okay, that one was tough, I know. But the basic concept here you should be able to do is figuring out that map, figuring out the percentage that should happen. And here, remember that this percentage includes ones that are double crossovers. And so you can figure out single crossovers by taking it away the double crossovers. But this is the basic, you know what the single crossovers should look like. Okay. Let's move forward. All right. So we talked about a little bit about finding the linkage group and genetic map in humans. DNA markers were one of the things. And we also talked a little bit about the looking at the mouse chromosomes as well. But that for humans, generally, when we're looking at linkage groups, we're finding DNA markers. Okay. All right. So in Drosophila, the gene for withered wings, smooth abdomen, speck body, chromosome 2, we have a map. So here's the map. Okay, so very similar map to what we had before. Then we have a female with withered wings and a smooth abdomen, mated to a male with a speck body. Okay. And the resulting phenotypically wild type females. Okay. Something to be clear on here is that we have 2 of them on the female and 1 of them on the male. Okay. And then we have to figure out the double crossover progeny. So this one's, it's a bit tricky, okay? Because you have to figure out exactly what does the female look like? What does the male look like in terms of that? And then all of the wild type females are then crossed here. Let's draw the map, and I think it's gonna help to understand what you would expect for the wild type and what you would expect for double crossovers, okay? Let me turn this off. And I can understand why this one would be a little bit confused, but you have to understand that you have to draw the map first. Okay, map. All right. All right, we'll make sure it's not downstairs anymore. Okay. All right, let's draw the map, and I'm going to show you. I'm not going to worry about this whole, like the distances right now. What I am going to talk about, though, is what the 2 that made it together look like, okay? So we have a withered wings and smooth abdomen. Smooth is the SM, okay? So the female who was mated, she looked like this. WHD, WHD, and SM, and SM plus plus. Okay, that's the female. The male, he looks like this. This is important to know because it's going to tell you about what sides things are on, okay? So let's blend them together and find out what we see. It's going to come out as all wild type, but the organization is going to be different, okay? Because they're heterozygotes, but one of them is going to be trans. Which one's going to be trans to the other 2? Which one's going to be trans? Who can tell me? If you mate these 2 together, it's going to come out with a fully wild type, but which one's going to be trans to the other 2?
Is it the specs?
Yeah, the specs will be trans. I'm going to write out what the offspring are going to look like, okay? We have this. Offspring now is going to look like this, okay? And I'm going to write it out with them on top of each other, okay? So I'll make a line. All right, offspring is going to look like plus one side, okay, from the father, WHD, mother, plus one side from the father, SM, mother, spec plus, okay? Mother, father. All right? I'm gonna write that down. It's father. There you go. Father up here, mother down here. So now we know what the parentals will look like, right? What are the parentals gonna look like? The parental offspring of this heterozygote will look, you're gonna have the most of them that are gonna look like plus SP and WHD SM plus, okay? That's what they're gonna look like because they're gonna all have the offspring here. The parental, the non-recombinant, okay? That's the parentals. Non-recombinant are gonna look like this. They're gonna have WHD, SM, SP. Because these all come from the test cross, okay? This is parental 1. And then we have the WHD, SM plus WHD, SM. That's the parental 2. Okay? Those are the parentals. So now we want to calculate the number of expected double crossover progeny. We're currently assuming no interference because we don't know what the interference would be, okay? So let's just assume no positive interference. Now we want to calculate the number of expected crossover progeny in 1,000 offspring, okay? So it doesn't even ask you what it is, but I wanted to work it out like this so you can see all of the possibilities and what your parentals would look like, and then what your double crossovers would look like. But you can just calculate it out.
Professor.
Okay? Yeah?
How did you obtain the second parental? Because I thought all the result would be like the first parental.
Because the parental looks like this. Plus SP. WHD SM plus, right?
Yes.
Whenever you do a test cross, it's always crossed to something that has all the mutant types. WHD, SM, SP. Okay? That's what this one's crossed to. So you always have one of these on the bottom. And you have this one on the bottom, okay? This comes from the test cross parent. And this comes from the test cross parent. Okay? The parental ones look like one of the chromosomes or the other chromosome. So if this was to be a completely cis individual, something that had all the dominants on one side and all the recessives on the other side, that's a heterozygote, it's gonna look like all wild type, but they have half of it. Then the parental offspring will look all dominant or all recessive. But they're going to be about equal. There's 2 types. Because it comes from the 2 chromosomes in the individual that is crossed to the test cross.
Got it. Thank you.
Okay, great. This should be reasonably easy to do. They're asking for the double crossover progeny. Okay, the progeny that's going to have positive progeny that is going to have a smooth abdomen and the other is dominant, and the progeny is going to have withered wings and a speck body and probably doing it differently, but it doesn't ask you that question. The deal is that 0.305 times 0.155. Okay, so it tells you that number. Let's make sure I'm correct, but I'm pretty sure that's the only thing you would do with double crossover. There's no subtracting out. Okay, 0.305 times 0.155 times 1,000. 47. There you go. All you have to do is multiply those two together, okay? I made this more complicated by actually doing the whole figuring out what sides they were on, but all it's asked, so it's asked you this one. So then we go, oh, now we have the interference for the gene. So that's 0.3, which means that if the interference is 0.3, that means that only what percentage of the double crossovers are expected to actually occur?
0.7.
0.7, correct. So 0.7 times our previous number here. Okay, so we have instead, erase some of this because you don't need this now. Okay, 0.7 times 0.305 times 0.155. Okay, so we do that. Times 1,000. 33. And it matches the number on there. I guess I'm not sharing my screen anymore, but there you go, 33. And that's the way I did it, is what I put up here, okay? That's the percentage that's actually happening times your expected percentage. So now you have 33. So if interference is 0.3, it means it's interfering with 30% of the crossovers. You only have 70% actually given, so you multiply these three together. All right. Back up here. Sure, I can see the chat. Okay. All right. Remember here now, we have offspring with the following phenotypes were also produced from that cross: withered wings, speck body, and then smooth abdomen, okay? So remember, if you are asked to determine how many offspring are expected to have these phenotypes, you must be cautious when relying on map distance. Map distance refers to the percentage of all detectable genetic exchanges. So since this class of offspring resulted from a single crossover only, you have to omit the contribution of double crossovers from the final answer. Okay, so this is asking you for the withered wings, speck body versus a smooth abdomen. Okay, so let's pull up. We have these are the parental types. Okay, so now this is going to matter. Let me stop sharing my screen for a moment, okay? We have the parental types that we expect. This parental type and this parental type, okay? So now we've got the ones that have withered wings and speck body. and spec body. Okay, they have a plus in the middle. And then they have a plus. And plus. Okay. Oh wait, if they have with their wings and they don't have that. Wait. Let's go do this. WHD. Okay. There. That's what it's going to look like in terms of its genotype. And then we have the so this resulted. This is our map here. This happened when just the, remember this is the parental that we expect. The SP here. It resulted in this crossover here. Okay, crossover in between those two genes created this. Okay. So the crossover in between those two resulted in this, remember? So we talked about that. That's, those two are 30.5% across. Now we have to subtract out the known number of individuals that, so we have the 33, remember, is a double crossover progeny. Now you need to figure out, from those, we figure out what the actual estimated single crossovers are, and then what else the double crossovers are, okay? So the estimated single crossovers here are 0.305. Let's go, it's 305, okay? So this should be 305. If it included none of the double crossovers. Take out the double crossovers we know that are happening, okay? Because we already figured out the number of double crossover individuals that we expect. Okay, so since that's 33, double crossovers 305 minus 33. So now we want to look at, and we see that the answer is indeed 272. Ta-da. Okay, you guys understand how I did that? First, I figured out where did the crossover happen, because I had these parental types that I expected, right? These are the parentals. A recombinant one has to flip something somewhere. So it would take this one and flip it, putting the WHD here and the plus down here, okay? So it happened here. We know that this is 30.5 mu apart. And we're looking for only the single crossovers, so we minus out what we already figured out to be the double crossovers, and that gives you your answer, 272. 272 single. And remember, the key here is that they're indicating that if a double crossover had happened, it would not look like this. Therefore, this is only the single crossover, therefore we only expect 272. Because that 33 would end up with the double crossover happening in a different phenotype. Okay. Did I lose anyone, or are we okay? Thumbs up. We're all right? Mostly? I see one thumb up. Have I lost anyone else? Are you guys okay? I see a couple, I see about 4 thumbs up. Okay. If you are confused and would like to talk about this further, again, we can set up an office hour, okay, where I can sit down and chat with you. All right. And then ask you another thing about how many offspring are expected to have the following phenotypes. And remember that the this asks you about all dominant or all recessive. And remember that our parentals are not that. Therefore, there would have to be a flip between these two. And then we have to do the same thing that we did above, okay? We do the 15.5, but then we minus out the 33, and now we have 122. You get 155, minus out the 33, 122, that's your answer. But you have to do the same thing each time because, again, the double crossover results in a different phenotype.
Professor, please, could you go over the part D? I didn't understand what it was asking.
Okay, yeah, and I'm gonna do that right now. Let's go, so again, part D. How many offspring are expected to have the following phenotypes? And it lists all 3 of them: withered wings, speck body, smooth abdomen. Wild type. Positive, positive, positive means, remember we talked about this is the actual parentals, the most common, because one of them's trans, not cis, okay? So in order to get positive all on one side, and to get all, so to get an all positive and an all negative, you gotta flip these 2, okay? Put this positive over here and put this recessive over here, okay? So the flip is happening in between SM and SP in this region, okay? That's where the flip is happening. We remember 0.155, 15.5 map units, okay? Are you with me so far?
Yes.
Okay, great. 15.5 map units, we have 155. 155, so there's gonna be 155 crossovers in 1,000 offspring. But remember, if we had a double crossover, it would not look like that. Instead, it would also have the WHD flipped, okay? So we don't want to include those in with the positive, 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 negative, negative, negative result. Instead, we go minus, and we already know it's 33, 122. That's how many offspring you expect to be all wild type or all mutant for all 3 of them. Because we know what the parental should be, we can point out what region it will flip in. It's flipping in the region that is this far apart. And we know we don't want to include the double crossovers. So this is how many we do include. Are you there with me, Mavis? Good?
Okay, thank you.
Okay, great. All right, I was asking you, again, it was basically the same question, okay? And then it does another question. Withered wings, smooth abdomen, or speck body. Remember, those are our parentals, non-crossovers. No, you don't have to worry about any of this because crossovers aren't happening. So therefore, we just figure out the frequency of the, if you minus out all of the other crossovers, you're gonna get about 573, okay? Because that takes out all of the other percentages of things happening, okay? So a double crossover doesn't happen, no single crossovers happen. So we add these 2 together, 0.305 plus 0.155, what's the percentage of that? Take that away and you have your parental frequencies, okay? Remember, it's asking about 2 of them. And so that is your frequency of parentals. And we know there's parentals, again, that's what we figured out at the beginning. Important to figure that out at the beginning so that you have the map to work off of. What should you expect be the most common? This will be 573, 57.3% will be parental. So again, it's just asking you to go through all of them. So, you guys there with me? I see that we had a lot of wrong answers, and so hopefully the walking through has helped you understand how you build it to start. Okay. I don't have any complex multi-part questions on the Blackboard quiz, okay? But you may see something like this pop up on your next exam, which is in a couple weeks. All right, we're about out of time, but if anyone has more questions, I am available to answer. If you have questions generally about, wait, how do I figure out wild type? Or how do I figure out parental? How do I even understand what the crossover would do? Why something cis and trans? What are you even talking about? Let me know. But that's the basic concept. All right. If everyone's good, then we can go. Again, if you are confused by the entire concepts of this, you understood nothing that I wrote here, you may be in some trouble. So I would encourage you, send me an email. We'll set up a time and I can basically sit for a half hour using this whiteboard again and walk you through the individual questions. We can work on some of the practice questions that are in the actual book. And I'm happy to do that. And I know that there's a complex, frustrating part to do these 3-part mappings, but you walk through it and it's not too bad. Again, remember this, the single crossovers and double crossovers do have a different phenotype, which is why it was asking us to find only the single crossovers. Because the frequencies are of every crossover and not just of the singles. Okay. Again, you can do it the opposite way and figure out what the interference must be instead of asking if the interference is this, what do you get? That's how I did it in my original one, as I walked you through how to find the interference from single plus double. Okay. Thumbs up, everyone. Happy? You ready to be done with today? I'm ready to be done with today. Again, I'm gonna, this recording has to process a little bit, and I'm gonna try to get the recording for the lecture and the parts that I lectured on up. I will post the rest of chapter 11 and more of chapter 12 probably by the end of the weekend. It's a lot to work around a toddler. All right, have a great weekend, everyone. Don't forget that this weekend you do have that Blackboard quiz, which you can take twice. You don't know what your right or wrong answers are, but make sure that if you get it wrong, then check. Go back through the questions and such. Stay safe, stay inside, go outside, but within your own houses. All right, bye everyone.